In this video, I'm going to show how I've added a complete CI/CD pipeline to IntelliconOps. The goal was simple: develop locally, test every change automatically, deploy it into an isolated staging environment, validate it, and then promote exactly the same tested release into production without needing an expensive enterprise build platform. Development starts in my existing IntelliconOps environment running in WSL, so my normal day-to-day workflow stays the same. When I work on a new feature, I create a feature branch rather than changing the main branch directly. That gives me an isolated place to develop and test the change before it becomes part of IntelliconOps. Once I'm happy with it, I commit the changes, push the feature branch to GitHub, and create a pull request asking GitHub to merge it into main. This is where continuous integration begins. GitHub starts a clean hosted runner and evaluates the code with Laravel and PHP tests, Python tests, front-end build checks, code quality checks and security checks. Those tests are part of the IntelliconOps codebase itself. For example, the Laravel application has dedicated feature and unit tests under V1 app tests, so GitHub is simply running the same automated tests that define how the application is expected to behave. Untrusted pull request code never runs on my trusted WSL deployment runner. If a required check fails, the change cannot progress. If everything passes, it can be merged into the protected main branch. After the merge, the release pipeline begins. A dedicated GitHub Actions runner inside WSL picks up the trusted code from the main and builds the IntelliconOps application, web and Python worker images. Each build is tied to the exact Git commit that created it and pushed to GitHub container registry using immutable image digests. This is one of the most important rules in the pipeline: build once. Production is not rebuilt later. The exact containers created here are the ones that must pass staging and, if approved, reach production. Those images are then deployed into a separate staging environment inside WSL. Development and staging may be on the same physical machine, but they use separate compose projects, networks, Postgres and Redis volumes, configuration and secrets. The same separation also applies to private cloud connectivity. IntelliconOps uses WireGuard to reach private workloads in Azure, AWS and GCP without exposing those workloads directly to the internet. Development, staging and production therefore each have their own WireGuard key pair and tunnel address. For Azure, for example, development uses 10.99.01, the router 10.99.02, staging 10.99.03 and production 10.99.04. AWS and GCP use the same pattern on their own 10.99x.0/24 ranges. All three environments can use the same cloud-side WireGuard router and UDP port, but the router sees them as separate cryptographic peers. A production private key is never copied into staging or development, preventing the environments from competing for the same WireGuard peer identity. So the environments are isolated not only at the application and data layers, but at the private network identity layer as well. To make the environments immediately recognizable, IntelliconOps also detects the URL and changes the sidebar color scheme automatically. Dark grey for development, lighter blue for staging, while production retains the normal IntelliconOps color scheme. Once staging is running, the pipeline runs smoke and integration tests across the application, database, Redis, Python worker and OpenTofu. It also checks the release SHA, proving staging is running the exact build created by GitHub. If staging fails, the pipeline stops and production stays on the previous known good release. Production is only deployed after staging passes. Once the staging checks are green, GitHub Actions continues the pipeline and promotes the same tested release into production. After deployment, the pipeline runs a public HTTPS health check and confirms the expected release SHA. If the check passes, the release is complete. If it fails, the previous known good containers are restored automatically. IntelliconOps also shows the environment and release identity in the interface within the footer, making it easy to see at what stage each of the staging and production environments are at. So although this looks like a CI/CD diagram, what I'm really building is a controlled software delivery process around IntelliconOps. Develop, test, build, stage, verify, approve, deploy and verify. And the principle throughout is simple. Build once, test everywhere and deploy with confidence. At this point, staging is running release 0427316 while production is still safely running the previous release, 5DB04016. Nothing's changed in production yet. And here you can see our Git repository, and if we look at our commit there that we had at staging, we look through our merge pull request and all the steps have completed successfully. And if we now look at our staging platform, and the footer shows our release, and now the production matches it, which means that it's at the latest release. So that completes the CI/CD journey from local development and automated testing through isolated staging and finally into production using the exact same validated release. IntelliconOps is continuing to evolve as a multi-cloud operations and automation platform. If you'd like to discuss trialling IntelliconOps, exploring a potential use case, or seeing how it could fit into your own cloud and infrastructure environment, please do get in touch. IntelliconOps, intelligent cloud operations with automation and control built in.